Well, I don't know about you, but I think it's time we learn about the impacts of mining. Man, look at that. That is impressive, huh? There's people who actually tour these things. Just they're amazing sights sometimes. But let's talk about this. Now, listen, as we talk about this, you'll be appalled. I mean, it's terrible. But you know what? We're all guilty of it. I mean, everything we have, like this rickety old phone of mine, my coffee cup I'm always drinking out of, just all kinds of things that we have in our lives. We need to extract these materials out of mines. And so there's no getting around it. So let's just learn how it works and see what we could do to mitigate the problems that these things cause. So let's just start with this. Oh, you know what? I'm going to try. I'm going to see what happens. Oh, if I click this, then I don't know how to stop it. So I'm just going to leave it there, even though it's kind of an eyesore. Okay, so here's the thing. Human beings have been mining since before we were really like, I mean, I guess we were humans, but for like thousands, tens of thousands of years. There's a place in Africa, the Gwinya mine, that is 43,000 years old, where people dug this hillside in order to get a mineral called hematite, which is a iron ore, to make a kind of pigment called red ochre that was common among prehistoric peoples as a way of painting their caves. People have been mining forever. They get obsidian to make arrowheads. So mining is something that goes all the way back to earliest human days. But in the modern age, we've gotten pretty good at it, and so we need to learn about how it's done and what are the different types of mining that are done and what are the problems associated with it. So let's start with this. Some types of mines are extracting materials that we just use directly. So you can dig coal out of the ground and sell that coal and burn it. You can dig gemstones out of the ground and just sell those gemstones. Okay, diamonds, rubies, sapphires, whatever. Okay, those are just straight extraction and sell. But that's not always the case. And a lot of times, what happens is we have to dig what we call ore, which is a rock material. Usually, it's a type of mineral that contains a metal that we want. And so we have to do something to this ore rock in order to get the metal we want out of it. This usually means either heating it or in a process we call smelting, or it involves using some sort of chemical extraction techniques. Yeah, chemicals. You can guess what that's going to lead to, right? So, but that's where we are. If we want these materials, that's what we have to do. Now, there's basically, we'll say, four main types of mining operations that happen. There's underground mining, where that's kind of what you think of, like where you're going underground and you're digging, like Dig Dug is a game we used to play when I was a kid. There's surface mining, which is really what happens the most, where we just dig holes in the ground. Okay, we sometimes call it strip mining or pit mining. Then there's placer mines, which are they're used a lot in Africa and other places in Canada. And then there's in situ mining, which is done for uranium, and it's not good. All right, let's go at it. Okay. Now, underground mining is what most people think of when they think of mining. It's like like Indiana Jones. I don't know. I don't play Minecraft, but maybe they have them there. The idea is that you're going to dig tunnels, you're going to dig shafts, you're going to put railroad tracks underground, and basically you're going to carve out the sides of these tunnels, brace them up with some sort of wood or steel like they have here, and then just extract the material and get it to the surface. Okay, and usually this is done. It's expensive and it's dangerous. I mean, these things collapse. There's gases that leak in. There's really a very, very dangerous thing. Uh, and you usually only do it for very valuable ores that are located somewhat deep. I mean, it's done for coal and things like that too, but it's mostly done for high value, deeply deposited materials. Surface mining, which just take a look at it, you can see this is really environmentally terrible. Okay, and this is what's done a lot. So surface mining is used when we have shallow deposits, often for low value materials like coal. Okay, and basically what it involves is taking off the overlying soil and rock material, which is called overburden. So you take the overburden away and you expose the material below, and you just go in with a bulldozer and just scrape it up and sell stuff. Now, the advantages, economic advantages of strip mining is that there's no cave-ins, right? There's no gas releases, so it's much more safe to do, and therefore you're not paying a lot of insurance, and so safer. It's also a lot less expensive. I mean, you can just get a lot more material more cheaply, unfortunately, just take a look at it. It is really destructive to the landscape. I mean, it does a lot of environmental damage, but we still allow it to happen because it's economically so feasible. Now, so my sister, Sarah, she used to work for a coal company in Bluefield, West Virginia, and she had to quit because basically her job as a geologist, like me, she got a geology degree, and then I kind of followed in her footsteps. But she had to decide whether or not it was more advantageous to dig a tunnel to get the coal, to dig a strip mine, or ready for this, to take the whole mountaintop off. And there was times where she had to say, "Yeah, we're going to take the mountaintop off." So what they'll do is they'll take a whole mountain, they'll blast it, they'll just remove all of this material in order to get the coal underneath it. And you can just see, like, when you take a mountaintop away, there's how do you ever recover from that? Okay, yeah, you get you get access to this non-renewable resource, and you burn that coal and it's gone. But that scar you left behind is really a hard thing to ever mitigate. It's pretty much there forever. Then there's placer deposits. Now, a placer deposit basically means that the minerals that we're after have been eroded from the bedrock that they came from, the mother lode, and then they've been carried downstream and deposited in gravel and sand deposits, usually along the shores of rivers, or in the beds of rivers. And so these are river deposits. So if you've seen like old movies where people are panning for gold, that's called a placer deposit. But when people find gold, they don't just keep going with their pans. They want to make money, right? So what they do, they go like, well, if a pan gets me some gold, a big operation where I'm moving all kinds of gravel out of the road is going to make me more money. So sure enough, people end up with bulldozers and whole mechanized factories for just digging up all of that gravel and then sifting out. Usually what you do is use running water, which of course now you're messing up the stream water, but you're using running water and you're taking advantage like you do with panning for gold for the fact that some of the things you're looking at have different densities. And so you can use this running water as a way of separating out by their densities. And then there's this one. And I don't know if this one's on the AP test, but it's worth talking about. So this is called in situ. In situ means in place, like you're not moving things where they are. Okay. So in situ mining means we're not going to dig anything. What we're going to do is, and it's mostly done for uranium. What you do is you build an injection well where you're going to pump a chemical down into the ground. You're going to let it move through the groundwater, dissolving uranium as it goes. Then you're going to pump it back up and you're going to extract the uranium out of the solution. Okay. And of course, as we're showing here, is you're going to put what are called monitoring wells to make sure you're not screwing up the groundwater. And if there is, you have to mitigate that. But, you know, messing with groundwater is not a good thing. But messing with, is probably better than digging all this up and just leaving this big open hole in the ground. So those are basically the ways we mine. Okay, let's just look at some of the problems associated with it, which some of them should be self-evident, but some of them are not. Okay, before we do that though, let's just have a little bit of background in mining terminology because you're probably not miners, right? So here you go. Here's some things. So the material that lies on top of the what we're after, we call that the overburden, and that's a term that does come up in the AP test. So you should know what overburden is. It's just the bedrock and soil that's on top of the deposit we're after. Ore is the rock material that contains whatever it is we're after, say gold ore or iron ore. Okay, so it isn't necessarily that there's iron there. There could be a rock that contains the mineral we want. So we call that ore rock. Okay. Now there's often waste rock that's embedded in with the ore rock that we don't want either. So this is the high value material. This is stuff that's just kind of in between that we don't want. So to take that out. All right. Now, once we take our ore rock, what do we do with it? All you have to do is you have to put it in a mill, which basically pulverizes it and grinds it up into smaller pieces, often almost to a powder. And then you have a concentrated amount of this material, and you have these tailings. And these tailings are basically this is what's left over when I extract what I wanted. Okay. Then I've got to take this concentrated ore and I've got to further refine it by either heating it or using some sort of chemical process in order to finally extract. You can't see here, so I'm just oh man, can I even make this go away? Can I show what's underneath there? So you finally get to the little bit of metal. I mean, and this can be, I mean, it's amazing how much of this it takes to get to one of these. Okay. It's shocking how much rock it takes to get a small amount of material that we actually want. I'm so afraid to click that button. Okay, so just think about this, okay? So it takes 3 tons of rock of gold ore to make enough gold for this one little ring on where I can't get it off, to make this little ring. Okay, 99 tons of ore just to get 1 ton of copper. So it is rather, it's not a particularly efficient method, but it's what we've got. It's what we've had for the last 43,000 years. It's what we're going to keep having until we run out of it. By the way, the ultimate mining mission is in space. Boy, they say the first person who successfully goes to space and lands a small asteroid will be the richest person who ever lived. There's so much money to be made there. Maybe it'll happen in your lifetime. That'd be cool, wouldn't it? Can I go forward here? Okay, so let's talk about the environmental problems. I'm sorry this one's going to go so long today. So the environmental problems associated with mining include the following. Okay, so there's dust that's produced that gets out into the air. It's minor, but it's there. Okay, the biggest one, the most important one, the one that's definitely going to be on your test in May, is called acid mine drainage. The water that comes out of mines, whether surface mine or subterranean mines, has a high amount of acid, or rather a low pH. It contains sulfuric acid. There's heavy metals often in the mining operation. So those heavy metals, which are usually very toxic, lead, cadmium, arsenic, those tend to get out into the environment. Now, often, like I said, in order to access the minerals in the ore rock, you either heat it or you apply chemicals to it, and those chemicals are often quite toxic. Another thing that happens is just this whole process tears through the landscape, exposed basically, strip mining, you're taking all the vegetation away, you're taking all the bedrock, all that's you basically have bare rock and dirt. And so of course it's just as soon as it rains, you're gonna have all the sediment washing into your streams. Clearly, strip mining destroys habitat like crazy, and it fragments it too, which makes it very difficult to promote biodiversity. And then also, if you're not using awful chemicals to extract the gold or whatever out of the ore, you often have to use high temperature uh, extraction techniques, which we call smelting, which are hugely energy intensive. And then there's just the fact that when you have strip mines, you have a loss of that cultural ecosystem service. Nobody wants to look out at a landscape that just looks like something out of the wrong side of Lord of the Rings. So let's just go through these one at a time. And again, I'm sorry this is going to take so long. So mine dust, let's start with that. Okay, so mine dust it's really more of a problem for people who work in mines, but it also can be carried down to communities immediately downwind. So basically, the process of extracting this stuff does make fine dust particles, which do drift in the wind. Basically, it's PM10, PM2.5. Uh, but worst of all is people who work in mines, especially coal mines, they experience something called black lung disease. This is gross, but look, this is a person who died who had a healthy lung. This is what their lung looked like. A person who died who worked in a coal mine, this is what their lung looked like. They died of this. It's called black lung disease. All that dust on his face is also going up his nose and his mouth and into his lungs. And man, it's not good. And so, without appropriate safety measures, it's not good for these people. Okay, but that's really as far as environmental damage, it's not really the biggie. The biggie is this one here: mine tailings. So mine tailings are basically, remember, this that leftover rock from which we extracted our ore material. And we've ground these into small pieces. So there's a lot of surface area, so it's very easy for oxygen in the atmosphere to interact with it, for rainwater to interact with it. And often we find there's two things in these tailings that are a problem. There's sulfur and there's heavy metals. And so what happens is these things get leached out by rainwater and also by reacting with oxygen, and they go on and they contaminate the streams and rivers, lakes, and groundwater. And this is really the biggest problem from apart from just habitat destruction of mining. So what we do with mine tailings is like you got to do something with them. What are you going to say? They usually store them on site somehow, and they often put them in these ponds behind dams. A lot of times it's because you got to try to. We'll talk about it later. Try to keep oxygen away from them because that's bad for them. So you have these retention ponds, and you can tell it's a copper mine if you remember from your chemistry class. This blue color is, I think, the copper 2 ion, I believe it is. They use that kind of blue. Anyway, so I can tell it's a copper mine. But basically, mine tailings are just a nightmare to deal with, and they're left over from every single operation. They are a real problem. Now, one problem with these mine tailings is that they're a problem forever. So it's not like the heavy metals will leach out of them in a few years or in a few decades. I mean, we're talking hundreds, thousands of years. These are going to be a problem. They were safely underground. Now they're not. And so it's an environmental problem that we're passing on to future generations. And remember, these are non-renewable resources. You use them and they're gone. Now, not necessarily, not if we recycle, but if you don't recycle, you use them and they're gone. Now, the biggest problem, by far, and the one you really have to know about is this one here. It's called acid mine drainage. So here you go. Are you ready? So coal and gold and iron often are associated with sulfur. So basically, uh, the mineral pyrite, which is sometimes called fool's gold, is associated. It's basically it's iron sulfide, so it's got iron in it. It's an iron ore. It's also associated with gold deposits too. So there's a lot of sulfur present there, and it reacts with oxygen and then rainwater, and also there's a bacterial component that can also accelerate the process. Very common aquatic bacteria. And so what that does, it tends to release a lot of sulfur into an aqueous environment where it quickly becomes sulfuric acid. I mean, just look at it; it's so gross. Environmental people like to take pictures of this just to shock people, and they should. It's gross. Well, I mean, it's sulfuric acid, and it's pretty concentrated, and it gets into the groundwater, it gets into streams, and it really, I mean, if you forget acid rain, this brings the pH way down and just pretty much kills everything in the stream. It just, I mean, it just looks so horrible, right? Because it is. So acid mine drainage is a terrible problem. It is associated again with coal, with iron mines, and with gold mines, and a few others. Okay, and the thing is, it's not just at the surface that it's a problem. Okay, by the way, all this stuff you see here, this huge thing, this is all mine tailings. Okay, and this is what's leaching out of them. And it's not just, and don't forget, these acids also will help leach out heavy metals. I mean, it's just this toxic stew of grossness. Also, do we find like people dig mines? So you'd think like, well, mine a little hole in the ground like this is not an environmental disaster, right? It's a lot less of an eyesore than say a strip mine. But groundwater gets in here and oxygen gets in here. And so we find is these old abandoned mines often have water coming out of them. When we sample this water, it's acidic. I mean, it's very acidic. It's got a lot of sulfuric acid in it. So these mines will just keep, basically belching out this acid for centuries unless we mitigate them somehow. Now, also, mine tailings contain heavy metals. And so over time, these heavy metals just accumulate and accumulate and accumulate. And most of these things are fat soluble, so they bioaccumulate in the area. So and acid in the mine water also accelerates the process of leaching these heavy metals out. So memo taken, right? These mine tailings are some bad stuff. Now, and if that wasn't bad enough, sometimes we just throw more bad stuff on it in order to get at what we want. So classic case is gold. So gold is very, very valuable, but gold is all what they found is that, you think of gold as like a eureka guy found gold, but often gold is like, you've got like a truckload of, it just looks like sand, but there's some gold in there. Maybe it's from a placer deposit. It's got gold in it, right? But the way you're going to get the gold out is not by looking for it, panning for it. No, what you're going to do instead is you're going to make a big pile of it, whether you had to pulverize yourself or it came to you already in that gravelly form. And then what you're going to do is you're going to pour this solution on it. And this solution, are you ready for this? It contains sodium cyanide. And the cyanide, as it leaches through here, you basically have it to where you have like a barrier here. Hopefully it doesn't have a hole in it. And then what happens is a quote, pregnant solution comes out. The pregnant solution is basically a solution that has gold cyanide in it. Okay, cyanide being a negative polyatomic ion. And then what they do is they just, you can't see that now, can you? Okay. So they process the metals out of it. Now they have what they call a barren solution that when we've taken the gold out, but it still has the cyanide in it, we put it back in here. So that's basically a method that's used for extracting gold, but it's also used, they can use like nitric acid and sulfuric acid to get at other target metals. So instead of using heat to do it, they'll use nitric acid, sulfuric acid, cyanide. And I mean, obviously, if that gets in the environment, if it gets in the groundwater, it's catastrophic. Now, if it's exposed to enough sun and light and air, like that cyanide, it can neutralize itself, but it doesn't always. Now, sometimes what happens is whole flocks of migratory birds will see this and go, great, there's a pond, let's land on it, and they just all die. Hard to find pictures of that. I mean, it's well documented, hard to find pictures of that. Mining companies don't want you to see it because that Contaminated groundwater doesn't make people upset, really. I mean, it does a little bit, but dead ducks freaks people out. Okay, it's just there's something visceral about seeing that. They make you not see that. Now, another thing that can happen is you can volatilize the cyanide. So if you have acid rain, which is not uncommon in a lot of areas, if the pH gets too low, the hydrogen ion reacts with the cyanide ion, forming hydrogen cyanide, which is a gas. I believe it might be one of the gases the Nazis used, to be honest. And then that carries out to the environment. Now, another thing is that when you're taking hillsides off, especially strip mining, pit mining, and it rains, it's going to carry away sediment with it. And that sediment is going to go into the river. So there's a lot of siltation, sedimentation of rivers that are downstream of these mines, which, this water here, prior to the mining operation, crystal clear. You could drink out of it 365 days a year. I mean, look at this environment where it's gorgeous, but you put in that mine and all of a sudden that water. Now, this is a good example of tragedy of the commons, by the way. A lot of times governments just gift people this land. Just go and dig. We want the economy. It's going to be good for us. It's going to be good for our country. It's going to make jobs. And that's true. But look what happens. It's like it destroys so much other stuff. So, we got to think about these unintended consequences. Now, another thing that happens especially with surface mining, is we get habitat fragmentation. Remember, we talked about biodiversity. Habitat fragmentation basically lowers biodiversity because animals they can't go they don't want to cross these open areas. And this is even after mitigation. They've actually planted stuff here. But what we find is that when we have habitat fragmentation, it really makes it difficult for especially larger macrofauna to be able to migrate around and have access to the type of hunting areas that they need in order to survive. Okay, almost done. There's a lot that's wrong with iron with mining. Okay, the other thing is a lot of things like say aluminum and iron and a few other ones. They require very high temperatures to be melted, or what we call smelted, out of their ore rock. So you take like that hematite, like the ancient people 43,000 years ago were using. Well, that hematite, if you melt it, out comes iron. Okay, and so basically, we have to heat these rocks until they're white hot, and this liquid comes out, and then we can treat this liquid to get the mineral, the metal out of it that we want. But come on, I mean, if you're going to melt that, it takes a lot of energy. And remember, most energy comes from burning fossil fuels. So now you put a lot of carbon dioxide in the atmosphere. The state I come from, Washington State, we have the Cascade River that flows. No, we don't. We have the Columbia River that flows through our state, and there's all these dams built along the Columbia River. It's a major, major river, and we have all this hydroelectric power in my state, which is great. But the reason they built it was not to power Seattle. It was not to power Spokane. It was not to power Portland. They did it to have energy to smelt aluminum because there was aluminum deposits nearby. Okay. Now, the last thing I'll say is this: that clearly, when you take mountaintops away, you really lose that cultural ecosystem service that is something that we really should not undervalue. People need nature, and when you look out and what you see is this, your heart just sinks. This should be a place where our spirits are free, where we feel like the world is this beautiful, lovely place, and instead, it looks like Mordor. If you're a Lord of the Rings fan, it just looks terrible. All right. So that's everything that's basically wrong with mining. And that's a lot. Okay, I know. I'm sorry it takes so much. But what are we going to do about it? Because you know what? You, me, and everyone else I know, we need these products, right? So we're not going to stop mining. But what we can do is we can put in place regulations to say, well, you got to mitigate. Okay, you can do it, but you have to do it in a way that's going to cause the least amount of damage, and you're responsible for whatever damage you do. And you have to make it not be a problem at all. Okay, so one thing is you can say, look, you have to take care of your old mine site. You got to make it not drain acid. You got to make sure that if you do strip mining or mountaintop removal, you got to go back in. You got to put in that. You got to take that overburden and put it back. You got to put soil back. You got to plant vegetation. You got to. It's going to take a long time for secondary succession to get that back to some semblance of normal. But you have to do it. You can't just leave this big pit in the ground. Right? You've got to try to do what you can to return it to a native state, which means you've got to have soil. You took that soil away, just put it back, which means you've got to not lose it in the meantime. You can't let it roll the road and go down the streams. Okay, so that's one thing we can do. Acid mine drainage is a real problem, and like I said, those mines can drain acid for hundreds of years. So basically, what can we do? Okay, so these are the common ways that they found that you can mitigate, and you will get asked about this on the test. I know you will. Okay, so here you go. One thing is covering the mine tailings with topsoil and vegetation, and maybe mixing some limestone into that topsoil. So why would we do this? Well, the two things you really got to try to keep this away from is oxygen, atmospheric oxygen, and water. Okay, well, you bury it. There's not you're keeping oxygen away mainly, but you're still going to have infiltration of rainwater. But if we put in some limestone, we might be able to neutralize that a little bit. So adding limestone or some other alkaline substance like sodium hydroxide or lime, whatever, can help neutralize the acid. Another way is just having like a clay barrier. Remember, clay is basically uh, not very porous, not very permeable. So if you put a layer of clay between the topsoil and the tailings, then you're basically keeping the oxygen and the water away from it, and that greatly reduces the amount of acid mine drainage. What a lot of companies do, they just store it in those ponds I showed you before, those blue ponds, whatever. They just underwater. There's no oxygen. If there's no oxygen, the likelihood of forming that sulfuric acid goes way down. Also, in underwater where they put it, the bacteria aren't going to be able to get at it. Right? But now you got these ponds. What are you going to maintain these ponds for hundreds of years? It's really it's a temporary solution. It's not a long term one. And then there's those subterranean mines. They keep leaking acid mine water, right? Sometimes it's called acid rock water too, by the way. So what do you do with that? Well, you know what you got to do? You got to fill those mines with something. You can fill them with water. You can fill them with some kind of rock. You got to somehow try to keep oxygen out of there. And it's expensive, right? And that's the thing is like we let people extract money from these natural resources, but we have to hold them responsible for mitigating the problem because otherwise they profit and we all suffer. It's just tragedy of the commons all over the place. So there basically here's just it's like a clay barrier. Basically, we call it a dry cover. Water and oxygen can't get in, so this is less likely to have uh, acid mine drainage. Also, if we try to maybe put something in here that will, well, here's a good picture. Like, so one thing we do is we can have like it's basically like a double layer of capillary pressure. So we have coarse and fine particles, and so capillary pressure kind of wicks the water up, and then it kind of goes over. So even though we're not using clay, we can still protect the tailings. Another thing is you can take the tailings, mix them with basically limestone pellets, and that can help neutralize it. You can put underwater, which is what a lot of people are doing right now. But there's different things. Okay, we'll move on. Recycling. Look, every Sunday I go out at 4:30 and I recycle for my week, and it makes me feel good about myself. But you know what? You may think it's a joke, but it's not. And here's why. Metals, especially aluminum, iron, it costs so much energy to extract, so much environmental damage done taking this out of the ground that if you recycle, you reduce that tremendously. It takes way less energy. It does way less environmental destruction. So when you recycle, you're really helping the planet a lot. And fortunately, that's something that municipal governments, especially here in Korea, have just mandated. You will recycle, and people have gotten used to it, and that's a good thing. And when I was a kid, it was just voluntary. Most people didn't do it. Now it's mandatory, and at least it is here, and it's not back home. They don't wear masks. They don't have mandatory recycling. But that's one thing you can do. Another thing is e-waste. Of course, this is kind of old school. Where do they find these phones? Man, those are probably worth a fortune. Right? Rated in a museum. All right, computers, TVs, cell phones. These things have a lot of metals in them that are very valuable. And so right now, people just throw it away when I'm done. But actually, what we're finding is instead of digging mines, in the Democratic Republic of Congo, what we could do instead is we can mine, down on the Han River. There's this gigantic pile of waste near like an Olympic stadium that's now all covered. There's gold in there, I mean, literally. Okay, you can go in there and mine that. But mainly, the best thing to do is just have an e-waste waste stream. So instead of saying like don't throw away these things, we want to have these things go to a place where we can extract the metals back out. And it's still energy intensive and involves chemicals, but it's better than digging holes in the ground. And it's worth saying that mining in developed countries is fairly well regulated and the workers are fairly well protected. Unfortunately, most of the mining in the world happens in developing countries where people do not have worker protections. And these people they're working like slaves, often as children, in no thought being given to their health, safety, security. So by recycling, we're reducing the need for this to happen, and essentially you're doing the world a social justice service by doing this. So that's mining for you. It's a huge issue, and it's one that definitely gets covered on the AP test. So hopefully you've got a handle on it. I'm sorry this went on so long.